All right, we're going to whip through the last piece of the review. We did this in class, but here's a quick recap. Things like p.2 being 30 degrees, and the knowledge that we have a 360 degree circle that all these other angles are developed from, and the fact that AT is a diameter. All these angles can be labeled in there, all these arc measures. Now how we go about those, like the 150 and the 30, it's because there's 180 between the two. We know because AT is a diameter. And same thing on the other side, NA being 14 and NT being 66. Comes from knowing that AT is a diameter. So with all those labeled, then we can go in and fill in things like angle AOP in this one. So AOP, trace carefully, is an angle, but it's the same measure as the arc that we know is 150 degrees. Central angles and measures of the arc are the same. And AT is an inscribed angle down here in the lower corner. It's half of the arc that it transcribes or intercepts. So we have 33 degrees for that angle down below. Then we have PAN, which is supposed to be written as arc PAN and arc APT. PAN is, you have to kind of count or look carefully. I'll go ahead and put this in a different color. PAN goes all the way around, and then from there we put together the 114 and the 150 for a 264 degree angle. So that's 2. I should use better color. Let's use red again. So 264. Yeah, Ethan wants crackers. You can hear that in the background. And then APT, the angle, yeah, crackers. APT is a diameter, 180 degrees. So 180 degrees. And I'll get some crackers for Ethan, and I'll get back to this. So let me pause for just a second. Okay, now we're back in action. What I can do now, number 13, this is tangents KL and LT. That instantly you should know that's a 90 degree angle because radii and tangents are perpendicular. And you should know that KT and LT, the two tangents, are equivalent, same length. That answers part A for us. What's true about KT and LT? Well, they're congruent. If the radius is 5 and TL is 12, then you got 5 for a radius, and then TL is 12. I cut this off. You can't see it on the bottom of my screen here. But rather than turn the page and make you look at a new screen, if KT is 12, so is TL. The idea is that you've made a right triangle. TL is 12, radius is 5, so you're going to do 5 squared plus TL squared, which is 12 squared. And that's going to get us TX squared. And that's just a Pythagorean theorem to go find TX. We did that in class, so that I just recap that. Now I'm going to go to the next couple of problems, so bear with me or pause if you need to. Okay, so that last one, so now I have it in place. I can actually write that in there a little bit better, so I can put that 5 and that 12 that I was talking about down here. There's the Pythagorean theorem you can do to solve for TX. Last one, KXT is 70. So KXT is this angle right there, 70 degrees. Remember, that's an angle. And if that's 70 degrees, and we know this is 90 in the corner by K, then we can just do a little subtraction or addition, however you look at it. Either way, you know the three angles add to 180 degrees. And this last angle then has to be 20 degrees. The way I think about it is that I've got 90 here for the K angle. That leaves me 90 for these other two. So 70 and 20 would make the other two. KTX has to be 20 degrees. Can you see where that KTX is? Vertex of T. That's that 20 degree angle I just pointed at. Last 14, find the missing side of the right triangle. So these are Pythagorean theorem. It says A and B are legs, C is the hypotenuse. So it's always, now, leg squared plus leg squared equals hypotenuse squared, or if you're going more sophisticated, you can always take hypotenuse squared minus a leg squared that you're given to get the missing leg squared. So either way you want to look at it, you can always do 5 squared plus b squared equals 10 squared, but you'll notice we're always going to end up subtracting this 5 squared term, and then so we get what we have down below here. So anyhow, that's my shortcut. If I have the hypotenuse and I need a leg, I usually do subtraction. But we'll go to b here. 10 squared plus 24 squared is c squared, and that's the setup. I'll do these both together at the same time. You know, this is 100 minus 25, and that's b squared. And I'm going to do an equal sign to the right here just so you can see that ends up being 75. So I'm going to square root both sides. And let me do that in a different line. Maybe I'll back that up. Let's say 75 equals b squared. That means b is the square root of 75. And if you remember in class today we talked about that's the same thing as 25 times 3. So this can be 5 square roots of 3. Take a look at our notes from today or class to figure out where that comes from. Remember, 25 is a perfect square, so its square root is 5. This is something you just have to know that these are equivalent, or be able to show decimal-wise that they're equivalent if you know one of the answer choices shows up on the multiple choice test. Number B, you get 100 plus 24 squared. So that'd be 676 equals c squared. And then the square root of that is 26 for c. Let me move on to the last one here. Excuse me. That's a squared plus b squared equals c squared. I'm going to do that. Hey, I've got the hypotenuse and I have one of the legs. I'm going to do 4 squared minus 2 squared. And that will get me that a squared. So that's 16 minus 4, which is 12, equals a squared. And then I can do the square root of 12 equals a. And if you remember, that's the same thing as 4 times 3. So I can write this as 2 square roots of 3 equals a. Both of them are correct. Square root of 12 or 2 square roots of 3 are both correct. One's simplified and one is not. All right, on to the next couple problems. Okay, the A and B are 30, 60, 90, and 45, 45, 90 triangles. So go find your latest drawing of 30, 60, 90, and 45, 45, 90, because I'm just going to reference the correct answers here. This means y is 3 times 2, because I'm going to a hypotenuse, which is 6. Okay, that may be too much information. Basically, y is 6, so I'm going to clean this up now and just show you what that looks like, but I get it from doubling 3. 6, and then remember to here, from short leg to long leg, it's times the square root of 3, so x is 3 square roots of 3. Cool. So times 2 from short leg to hypotenuse times the square root of 3 from short leg to long leg. That is the law of 30, 60, 90. And if you couldn't tell that was the short leg, the 60-degree angle is the indicator of where the short leg lies. All right, a B is 45, 45, 90. The other leg is also 6. Hypotenuse is always the square root of 2 times bigger than the legs. Bottom one, A, B, and C are referenced to 1 point, 25, negative 32. If you reflect over the x-axis, so 25, negative 32, let's say point A is there. If I reflect over the x-axis, A prime, if I can get this to work, is up above here. Sorry for all the extra dots, it's doing something funny. So A prime is just above it that way. So instead of being right 25 down 32, it's going to be right 25 up 32. So that point is positive 25, positive 32. To rotate 90 degrees clockwise is the same thing as 270 counterclockwise, which we have a little system for. 270 counterclockwise means you swap the x and y and you change the second term. So we'll go negative 32. So there's negative 32. And then what I put is the 25 in the back position. But that's the one I changed the sign of. So I make that now negative 25. So there's the coordinate of a 270 rotation, which is the same as the 90 degree clockwise rotation that I wanted. 270 counterclockwise, which is the method we know. We know how to do counterclockwise. That allows us to do 90 degrees clockwise, its complement. All right, if you translate it by its vector, remember this just tells you what to add to the x coordinate and what to add to the y coordinate. So I can take the 25 and I take away 10 and I get 15. I can do negative 32 and I can add the 12 and I get negative 20. And that's my new coordinate. Well, it looks like a 29, doesn't it? So let me make that a little better, 20. There you go. And there's 15, negative 20. You just add the vector values to the original point, 25, negative 32. That's page 2. We'll be back to others later.